te whānau, no mai haere mai, and welcome to another Daily Demos. Today we're going to be doing science. So we have Kind Koala along with us, who loves science. But before we get talking about the scientific method and our inertia tower that we're building today, let's do our karakia, mahunga ki raro. Kia inoi tātou, manawa mai te mauri nuku, manawa mai te mauri rangi, ko te mauri KO he mauri tipua, ka pakaru mai te pō, tau mai te mauri, homi e, hui e, taiki e. Ka pai. Alright, we're going to look a little bit at the scientific method while we're doing our experiment today, because you are your own little scientist, as am I, and so is Kind Koala. Anybody who's doing an experiment or a scientific investigation is a scientist. So you need to learn the method that all scientists follow when they're doing an experiment. So our first step is question. We need to have a question that we're trying to answer. Now usually this would come out of some exciting research that we've done as a class or yourself, but because it's just me here with Daily Demos, I've got a question for you. How does inertia work? Now you're probably going, what on earth is inertia? How does inertia work? That is what we are going to try and answer today. All right. Now, the first thing that we need to do is we need to make a hypothesis. So I'm going to give you a little demo of what we're going to be doing, and I'd like you to make a prediction. A hypothesis is a prediction or a guess about what you think will happen. So we're going to be stacking these cups, but in between the cups we're going to have pieces of card or paper. If I put lots of cups on top of each other with cardboard in between, what's going to happen when I pull a piece of card out? I'd like you to make your hypothesis. I'd like you to predict, to guess, what do you think is going to happen? Okay, now the next step, now that we've made our guess, we've done our question, is materials. Materials is what you need to do your experiment. So here is what you need. The first thing you need is plastic cups, or blocks are even better if you have any kids playing blocks, or some other heavy blocks, like maybe some Lego creations that you've made. You could make them into little blocks. Anything that's a similar weight to a plastic cup or to a heavy wooden block is fine, as long as they stack really easily. So these cups stack really easily and wooden playing blocks stack really easily. But things like cans don't stack super easily, so try and think of objects you can try that can stack. Okay, so you need plastic cups or blocks. You need card or cardboard. Now you can use the back of an old muesli box, Weet-Bix box, box of tea, any kind of box that you have. I've got some old recipes that were sent to me that are made of kind of a thick card. So as many pieces as you like, depending how high you want to make your tower. And we're going to cut them into A5 size, which is this size. So half the size of a normal piece of paper. The next thing you need is either a hole punch or some scissors, because we're going to be making a hole in each piece of card. And the last thing you need is string, or you could also use twist ties or pipe cleaners, anything that you can attach to the card to use it to help you pull. Now you don't have to have string, that's not super important. You can just pull with your fingers. Okay, so what's our next step? We've questioned, how does inertia work? We've hypothesized. What's our guess? What do you think will happen when we pull the card? We've discussed our materials, and now we're going to do our procedure. Our procedure is the steps that you take to do your experiment. So I'm going to tell you those one by one, and then we're going to find out what the results are. So what actually does happen. So the first step in your procedure is to get your cardboard, and you're going to cut your cardboard so that it is about A5 sized, which means half of a normal piece of paper. So do that to all your cardboard. Oh, and if you see Cheeky Bee, let me know. Okay, I've cut my card. My card's ready, but now I need something to help me pull it as hard as I can. Because pulling with fingers is okay, but if we can pull with string, we can pull extra hard. So I'm going to get my hole punch, or you could get your scissors, and I'm just going to make a hole at the little end in the middle, like this. See that? Okay, I'm going to do that to all my pieces now. Okay, I've got holes in all of my card now. So now I'm going to attach some string, or your pipe cleaners, or your twist ties, or whatever you like. But you can skip these steps altogether and just not have holes and not have string. It's up to you. Okay, I'm tying the string on with a couple of knots. Don't tie so tight that you break the paper. Not too long, maybe the length of your forearm. Okay, I've finished making my card with my string. Now there's only one more step, and it is to stack your cups or your blocks, or whatever you've chosen. I recommend big wooden blocks. To stack them with your card in between. So let's do that. Try and stack them so that if you have cups, so that they are going to, they are already stacked on top of each other. Don't put the cup kind of over here or anything. It needs to be right on top of each other. Okay, I'm going to start with 4 cups. Now, I would like you to see at home if your prediction was correct about what you thought would happen. Okay, what you're going to do is pull your string really, really hard and really quickly. Because we don't want the whole thing to fall over, you can hold onto the card from the next one, the next cup. Ready? 3, 2, 1. Look at that. What happened? Well, let's see if it happens again. Next string, pull hard. Okay, and final bit of string. Let's pull really hard for this one. Make sure it's stacked on top. Just remove it if it's not. Wow, look at that. And I didn't have any cups that were tumbling off, that were being pulled away with the card. Why could that be? So now we're up to the results part. We've done our procedure. I've described all the steps to you, but the results is what happened. So tell someone around you at home, or have a think to yourself, or tell me what happened to the cups when you pulled out the card. That's right, they still moved down. Even though the card was pulling out, the cups moved down and stacked. So what's the science behind that? Well, let's take a little look at the board. So why does this happen? Well, this is part of our conclusion. A conclusion looks at the answer to our question and reflects on whether or not our hypothesis was correct. So your hypothesis, your guess, was it right? Did the cups do what you thought they'd do? Well, let's reflect on why that happened to the cups in the end. Have you ever caught a train and notice that it keeps on moving even when the brakes have been put down for it to stop. It moves for a little while longer. Or have you ever noticed when you put the brakes on your bike that it keeps on moving for a little while after you try to stop? This happens in a lot of vehicles, and it's because of something called inertia. Inertia is the idea that an object doesn't want to change what it's doing or how it's moving or not moving. So if it's rolling downwards like a bike, it doesn't want to be stopped, so it resists and keeps going for a while. Or if it's a train and the brakes are put on, it doesn't want to stop, so it just keeps rolling a little bit longer. This is because of Newton's law of motion. Newton's law of motion says that an object just wants to keep on doing what it's doing or what it's not doing, unless something else comes along, a force comes along and tries to change it. So a train just wants to keep on going unless the brakes come along and try to stop it. But it keeps wanting to move, so it rolls a bit longer. So that's exactly what happened with our cups. Our cups just want to follow gravity. Gravity is the force that pulls us down to earth. That's why if you drop something, it falls straight to the ground. These cups want to follow gravity, and they want to keep pressing as far down as they can. So when the cardboard is removed, that means going down and stacking onto the next cup. But we're pulling out cardboard, and that's making a little force, a pulling force. But that force is not quite enough to stop the cups from doing what they want to do. They want to follow Newton's law of motion. They want to keep doing what they're doing and follow gravity and go down. The cardboard being pulled out from between the cups wasn't enough of a force to stop the cups from moving down and following gravity. Now, you might have noticed when you did it that the cardboard was almost enough to move the block or move the cup over so much that it didn't stack. Sometimes they just slid slightly over. So I wonder what would happen if you tried objects of different weights, or if you tried pulling faster or slower, what would happen? So when I pulled the cardboard out, the cup fell down because it wants to just keep doing what it's doing. And because of inertia, it's trying to stop itself from changing that movement. It doesn't want to stop moving down and following gravity, so it tries to stop itself from moving sideways with the paper. And so the next cup drops down. And then again, when I pull out the cardboard, it's almost enough to move my cup over and stop it from stacking. But because of inertia, because of how the object wants to stop itself from moving in any other direction, it just wants to keep going the way it's going, which is down, the cup doesn't slide off with the cardboard. It follows gravity and it falls down and stacks on top of the other cups. Now let's look at a quick other experiment to see what happens when we look at inertia, or we look at Newton's law of motion in a different way. There is another experiment that you can try really easily at your house with just a stick and some boxes of tea, or you could make some origami boxes, or if you have any other boxes that are exactly the same height and weight, and predict. What do you think is going to happen? We're back to our predicting stage, our hypothesis stage. What do you think is going to happen when I get my stick and I swipe it, pushing this bottom one all the way out? Is it all going to tumble over? What do you think is going to happen? Okay, now let's do our procedure. Our procedure is very simple. Our steps. First, stack them, whatever it is that you're using. Second, get your stick and swipe the bottom thing on the pile. Okay, now let's see what our results are. Let's get ready. Watch carefully. 3, 2, 1. Huh, what happened? I didn't have any tumbling, it just swiped right out. Let's try the next one. And the next one. Wow, so this works in exactly the same way. This is inertia in action. So for this experiment, we had our T stacked up, our T boxes, and when we got our stick, we very quickly whacked it just on the bottom box. Now, because of Newton's law of motion, which says that objects just want to keep doing what they're doing unless a force comes along that is greater and that changes it, these T boxes want to stay still. So when the stick comes along and whacks out the bottom box, all of the boxes move down, and the only box that moves out is the bottom one. Now, the reason for that is because these boxes want to stay still. They don't want to change their movement or their motion. They are currently resting. They are still. Now, there are two forces acting on these boxes. The first force is gravity. Gravity is always pulling items down to earth. So these boxes want to follow gravity and stay pulling down to earth, going downwards. But the second force we're applying is with a stick. But this stick is actually only touching the bottom box. It's not touching these two. So this force is enough to overcome gravity for the bottom box. It gets pushed out because the force is great enough to stop it from just going down and make it go sideways as well. However, these boxes just tumble down neatly to the bottom, and that's because the stick did not touch these boxes. So these boxes did not have a force acting on them that was greater than gravity. So all they did was keep doing what they're doing, which is Newton's law of motion. They just want to keep going down and then stay still. So they just follow gravity. Ka pai, I hope you enjoyed our experiments today, our inertia tower experiments. Try finding anything you like at home and experimenting with what happens when you use different objects of different weights, different sizes, and give it a go doing the stacking or doing the swiping. Okay, it's time for our karakia. Mahunga ki raro, heads down. Kia inoi tātou, ka pā ki tua, ka pā ki waho, ka pā ki te whare, ka pā ki te roa, ka pā ki te pau e tūnei. Kia mā te araki, kia mā te tauira, nō hau e roa tau, e tāne te wairoa e. Whānō, whana, haramai te toki, homi e, hui e, tāiki e. Tūmeke, awesome. It's time for me to go. See you later. Have a great afternoon and I'll see you for the next daily demos. Ka kite.